Right, today we are going to do theory 3 of circle geometry. This is theory 3 of circle geometry, circle geometry. We have in theory 1 and theory 2 yesterday. So today theory 3. And theory 3 states opposite interior angle of a cyclic quadrilateral supplementary. This means they add up to 180 degrees, right? This means if this is y, right, the other angle is 180 minus y. Okay, what I want to talk about is a cyclic quadrilateral on its own. I want to talk of a cyclic quadrilateral on its own. What is a cyclic quadrilateral? A cyclic quadrilateral on its own is a quadrilateral inside a circle. So when you're talking of a cyclic quadrilateral, we are talking of a quadrilateral inside the circle with all its corners touching the circumference of the circle. With all its corners touching the circumference of a circle. Let's take for example, or one of the most difficult and error which we make when answering this, it will be given like, right? And then this one is not a cyclic quadrilateral because the other corner didn't touches the circumference. So we need to see all the corners of the quadrilateral which we find inside the circle touching the corners of the circle, right? So if this angle is x, let me talk of this angle in this case. If this angle is x, this angle is 180 minus x. So we said opposite interior angle of a cyclic quadrilateral are supplementary. They add up to 180, which means we subtract the value of the given angle to get the opposite side of the given angle. That's it. That's how it goes. So we don't want to consider this as a cyclic quadrilateral. That's why I removed it. I don't want to consider this as a cyclic quadrilateral, but I consider this one as a cyclic quadrilateral because all of its corners touches the circumference, which is the main point to be considered, right? Let us go for another example. Let us draw another example and try to find its values. I want to fill this circle. I draw a circle here with me, and this is a cyclic quadrilateral. It doesn't matter, the shape doesn't matter, but what matters is all the corners must touch the circumference. The shape doesn't matter, but what matters is all the corners must touch the circumference, right? Look here. Let's say this angle is 60 degrees, right? So we are asked to find y, right? How do we find y? To find y, we need to say 180 degrees minus the given which is 60 degrees, right? Here we'll get 180 minus 60, we get 120 degrees, so that's the value of y. Okay, let us put another one. Let's say this is 50 degrees, right? Let's say this is 50 degrees. So what is its opposite? Its opposite is 180 minus 6. Let us make it x. Its opposite, how do you find x? Its opposite is 108 degrees minus the given angle, which is 50. 180 minus 50 degrees. The answer which you are going to get there is 130 degrees, and this is x, right? So this is very, very simple to attack. But what you have to consider before answering any question is whether it's a cyclic quadrilateral or not. I said a cyclic quadrilateral. I've got all of its corners touching the circumference. Right, now we are going to theorem number 4. Theorem number 4, it states that opposite interior angle of a cyclic quadrilateral is equal to opposite exterior angle, which means if this is the first thing is to identify the interior and the exterior angle, right? For example, let's just draw a circle here. Right, let's just draw a circle here with all its corners touching the circumference. Right, so this is the interior angle and this is the exterior angle. Right, if we can draw another circle, right, we had the interior and exterior angle. So identifying the interior angle is the core issue here, right? And remember, we once said a cyclic quadrilateral has got its corners touching the circumference, has got all its 4 corners touching the circumference. So I am now removing this because it's part of the journey, but it will help us understanding how the journey looks like. Right, now we said opposite interior angle of a cyclic quadrilateral is equal to opposite exterior angle, Now, let us try to get deeper, and I want to prove this in this particular example so that we understand it deeper, right? If this is x, this is x as well. If this is x, this is x as well. So if this is 10, this is 10 as well. If this is 30, this is 30 as well, right? Let's just have a simple example here. I am going to draw this circle. I am using this circle. Right? So I want to say here is 100 degrees. So we say this angle is equal to this angle. So this is also 100 degrees, right? So that's how it goes. Opposite interior is equal to opposite exterior. So we need to find the interior angle which works with the opposite exterior or which works with the given opposite exterior angle, right? Now I want to prove what this law says using the theory number 3. I want to prove using theory number 3. I have a circle. Inside the circle, I have a cyclic quadrilateral, and this angle is 60. Remember, theorem number 3 says opposite interior angle of a cyclic quadrilateral are supplemented. Opposite interior angle of a cyclic quadrilateral are supplemented, which means two opposite interior angles add up to 180 degrees, right? So if we are given 60 here, for us to get this angle, we need to say 180 minus the given 60 degrees. We get 120 degrees. So here there is 120 degrees. This is a straight line, and the concept of a straight line, it says straight line is add up to 180 degrees. Straight line add up to 180 degrees, right? And they are saying this angle is 120 here. Is 120. What about this angle? This angle, we are saying 180 minus 120, we get 60. So this angle is 60 degrees. As employed by the law, we say opposite interior angle of a cyclic quadrilateral is equal to the opposite exterior angle, right? So I want to put one more example which you can consider as exercise. One more example which can be considered as exercise. With me here, it's a cyclic quadrilateral. The shape doesn't matter. What matters is all the four corners of the quadrilateral touches the circumference. So here we have got 70 degrees. So I am leaving it as an exercise. So I say find x and y. I'm leaving it as an exercise.